Let's take a look at the final exam review problem set for Chapter 4, which dealt with matrices. We are looking at the basics of matrices in terms of the dimensions and some of the logistics that we have to understand in terms of adding and subtracting matrices, and then, of course, multiplying matrices. The first example problem here deals with adding matrices, and it also involves the scalar matrix. So we have matrix A, which is this matrix here. It is a 2 by 3 matrix. Let's remember that when we are defining the dimensions of a matrix, those dimensions are rows, which are horizontal, rows by columns. Columns are vertical. So matrix A has 2 rows, 1, 2. It has 3 columns, 1, 2, 3. So matrix A is a 2 by 3 matrix. Matrix B, as we can see, is also a 2 by 3 matrix. It has 2 rows and 3 columns. Therefore, we are able to add or subtract these matrices. In order to add or subtract matrices, they have to have the same exact dimensions. So it wants us to evaluate A plus 2B. So we are not only adding matrix A plus matrix B, but we are first going to apply a scalar multiplier to matrix B. So we are essentially going to multiply each value, each entry in matrix B by positive 2. And then we are going to add that new matrix to matrix A. Again, we are basically following our order of operations. We are first going to multiply 2 by matrix B, and then we are going to combine or add the entries at each address for matrix A and the resulting matrix 2 times B. So let's take a look at what that looks like down here. Matrix A, we just recopied it here, plus 2 times matrix B. You can see matrix A is just recopied down here below. And now this new 2 by 3 matrix is representative of 2 times matrix B. And you can see each entry is the entry from matrix B doubled. 1 times 2 is 2. Negative 9 times 2 is negative 18, and so on. Then we are adding this matrix with matrix A. And when we add or subtract matrices, we are simply combining the entries or the addresses with each other, the value of each address. So this address here in address 11, row 1, column 1, is going to be combined with the value in address 11 or row 1, column 1 of this matrix. So it's 1 plus 2. That's where we get the value of 3 in row 1, column 1 of our resulting matrix. And then that process takes place for all 6 entries. Negative 3 plus negative 8 is where we get negative 11 from in the resulting matrix, and so on. So that is how we both add and or subtract matrices, and that is also how we would apply a scalar multiplier to a matrix if that's part of the problem as well. Okay, now let's take a look at the next example problem, which says for matrix S, which is a 2 by 3 matrix, and matrix T, which is a 4 by 3 matrix, what are the dimensions of ST, which is matrix S multiplied by matrix T? Well, as we can see here, we are unable to multiply matrix S by matrix T. Matrix are defined in their dimensions as row by column. So this matrix has 2 rows and 3 columns. This matrix has 4 rows and 3 columns. In order to multiply matrices, the columns of the first matrix have to equal the rows of the second matrix. So when you line it up and order matters, these two numbers have to be equal. 3 is not equal to 4, therefore no solution. We are unable to multiply those two matrices together. We take a look at our next example, which is a multiplication problem. Matrix P times matrix Q. Evaluate PQ. And in this case, matrix P is a 2 by 3 matrix. Matrix P is a 2 by 3 matrix, and matrix Q is a 3 by 2 matrix. And we can see here that the columns of matrix P, which equals 3, is the same as the rows of matrix Q, which is also 3. So we are able to multiply matrix P times matrix Q. Now, the resulting matrix, the product matrix, when we multiply matrix P times matrix Q, or we multiply a 2 by 3 matrix by a 3 by 2 matrix, that resulting product matrix will have the dimensions of the rows of the first matrix and the columns of the second matrix. That is where we get our resulting 2 by 2 matrix from. So you'll see that matrix PQ is a 2 by 2 matrix, and that's where we get those dimensions from. And you can go ahead and just set up that 2 by 2 matrix before you start doing your calculations. Now, after you have your 2 by 2 matrix set up, or whatever the dimensions are of your product matrix, the process of finding the value of each of these entries is by adding the products of each entry in a specific pattern. And that pattern is this. Let's take a look at this address right here of our 2 by 2 matrix. This address is row 1, column 1. I am going to multiply row 1 of matrix P by column 1 of matrix Q. And I'm going to work left to right for my row and top to bottom for my column. So you'll notice these multiplication problems here, and you'll notice me adding these products together. So I'm taking positive 2 and multiplying it by negative 2. That's my first multiplication problem here, going from left to right. Row 1, column 1. 2 times negative 2, plus my next value, negative 1 times negative 1. You see that here. Plus 3 times 0. You see that here. That sum is going to be my row 1, column 1 value of my product matrix. And we can see here that 2 times negative 2 is negative 4. Negative 4 plus positive 1, because negative 1 times negative 1 is positive 1. So negative 4 plus 1 is negative 3. And then negative 3 plus 3 times 0 is 0. Negative 3 plus 0 is still negative 3. And that's where the value negative 3 comes into play here. We take that process for each of the entry parts of the product matrix. For example, if I want to take a look at this value here, this entry, this is going to be row 2, column 2. Row 2, column 2. So I am going to take row 2 of matrix P, and I'm going to multiply it by column 2 of matrix Q. Again, I'm working left to right and top to bottom. So you'll see here, negative 1 times 2 plus 3 times negative 1 plus 0 times 3. I'm getting those values from here. I'm taking negative 1 times 2, 3 times negative 1, and 0 times 3. When I combine those values, I combine those products, it results in negative 5, and that's where negative 5 comes from. That process is then repeated for each of these entries, for row 1, column 2, and also for row 2, column 1. And that is how we get our product matrix. And we can apply that to each of our multiplication problems. So for this last example, matrix A is a 2 by 2 matrix. They want us to evaluate A squared. That is simply matrix A times itself. Matrix A times matrix A. We can see that we can do that because these two values are equal. Our product matrix will be a 2 by 2 because those are my two outside values. I can set up that 2 by 2 matrix, and I can go ahead and take that same process here in terms of taking the sum of the products of row 1, column 1, when I am going left to right and top to bottom to find the value that goes in this entry. And then I repeat that process as well. Hope this helps. Thank you very much.